quite happy to have new people come to the Arboretum. Of course, we love it if you join as a member and those sorts of things too. But tonight we have Dr. Mitch Wagener from Western Connecticut State University. We used to work together there, so that's how I know Mitch. And he's a terrific speaker and college professor. And his specialty now is climate change, global warming, that sort of topic that is so important right now. And I am assuming that most everyone in the room is a believer. And I don't have any other special things on you. If you want to introduce yourself, that's great. Thank you for coming today.
I'm from Missouri originally, the Ozarks, southern Missouri, so if I sound like a hillbilly, it's because I am. My grandmother was from Cooter, Missouri. My grandfather was from Hontubbee, Oklahoma, so you can kind of get the idea. I went to college, University of Missouri, and then I went to grad school at the University of Alaska Fairbanks. So, master's and PhD up there, and then I've been at Western since 1996. And so, quite a while. I teach all sorts of stuff, including entomology. Ecology is my field, and what I've been focusing on, gradually increasing the amount of things I've been doing in this field, is climate change education. Not only for my students, because, you know, to be educated and good citizens in the world today, you have to understand what's going on around you. And it's becoming stronger. And we have to deal, and we have to understand generally what's going on, but also the general public as well, including high school classes and all the way up to university classes. So I'll open it up at the end for questions. Can you guys hear me back in the cheap seats? Okay.
Yeah.
I can bell you. I can fill up a big room if necessary. I've got a little bit of allergies going on here, so if I cough in the middle of it, don't take it personally. I'm not infectious, probably. All right, so is there a way we can dim the lights? I don't want anybody to trip and fall on the way in. But is that okay? Yeah, I think people can probably see. All right. I'm old enough that I remember the Apollo moonshots. And one that orbited the moon but did not land was Apollo 8 in what, 1968, I believe? Some of you all may remember that as well. And the amazing thing, one of the amazing things about that trip to the moon was that the astronauts took pictures of the Earth on the way back. And they were the first, this isn't that picture, but I'll get to this in a minute. They were the first pictures to see the Earth in one frame, in one photograph. And you see this beautiful blue marble in the total black of space, some of the pictures they took had a little bit of the moon in the foreground. So you can see how different they are. But they were beautiful. We had never seen anything like them, because we had satellites that could take little pictures, but we didn't have the big picture, right? Of course, now we can take pictures that are much higher definition, that are in fact mosaics of pictures taken from satellites and are electronically put together. I showed this picture at the beginning of all of my talks. This is one of the more recent high-definition ones, for a couple of reasons. One is to show something about the Earth that you can only see from up there. You can't see it from down here because our perspective is too small. And one of those things is how dynamic the atmosphere is. those clouds, if you were to sit and watch them, would move around. You notice that they do little curlicues. They do those curlicues because the Earth is spinning. It's called the Coriolis effect. And you can also see this line of clouds right here. Okay. That is the latitude that at the season these pictures were taken, the sun was the highest in the sky. Because it is that point that the sun is the hottest, which warms the earth right underneath it, causing the air to warm and to move up. And as it moves up, it cools and becomes less able to hold on to the water that's in the humidity in the air, and it condenses out as clouds. And this, you can see as this line of clouds that goes around the earth. That's the solar equator at that particular time. The earth is a living thing in that respect, in that it's in motion constantly. The other thing to notice is just how beautiful the place is. This is not especially if you could see those old pictures with the moon in front, which is a barren rock. It's beautiful in its own way, of course, but the earth, as seen from this perspective, is just gorgeous. It is our home. As of now, it's our only home. We may in the future have other homes, but right now we don't. We should take care of it. Now, in the modern world, there are a number of problems that societies and cultures and the human race have to deal with. Some of you can probably tick them off on your fingers, the ones that you're the most keyed in on, whether it be diseases or overpopulation in some countries, or wars in other countries, or you name it. Everyone's keyed in or clued into some of these because they're interesting to us and we're particularly concerned about them. The background, though, for all of it, whether it be the difficulty of supplying food to certain parts of the world, whether it be people having to get up and move to other parts of the world because they can no longer make a living and feed their children where they were before, whether it be the loss of the rainforest or what have you, one might say the elephant in the room is, but I'm going to say the woolly mammoth in the room because they were bigger than elephants. And I just happen to like woolly mammoths. The woolly mammoth in the room, in its appropriate metaphor, is climate change. Because in the background of everything, affecting everything, is climate change. Have you ever heard of a novelist, Margaret Atwood? Yeah. She wrote Handmaid's Tale and other things. She has said, and I can't tell you where she said it, but she said, climate change is everything change. And that's true. So, the big thing in the background that will affect everything else that we do going forward as a human race is climate change. Now, sometimes people get confused. Confused between the climate and weather. Okay, climate, so I thought I'd better clarify. Climate is the statistics of temperature, humidity, atmospheric pressure, and all this stuff over a large area, over a given amount of time, a long period of time. In fact, statistically speaking, you can't really describe a trend in climate with anything less than 30 years worth of data. Okay? You can look out the window and say, wow, it's really cold out there tonight and we're going to have some snow later. That's not climate. That's a result of climate, but it is not climate by itself. That's weather. Okay? So weather are these same things over periods of up to 2 weeks. And the models which are used, the mathematical computer programs that allow us to predict the weather are different than the ones we use to study the climate, because climate is at a different scale of time and space. You can say that climate is what you expect, but weather is what you get. Or, if you have teenagers, you'll understand what I mean. Climate is personality, but weather is mood. Or if you remember what it was like to be a teenager. All right. As you know, because you've been paying attention to the world, we've had a lot of hot years recently. One of the things that other people often confuse is what's happening in our backyard as in comparison to what's happening in the world as a whole. The world is a big place from the perspective of us small human beings. The 48 contiguous states make up only 1.5% of the world's surface. That's all the states, California and Montana and Texas included. Connecticut, of course, as you know, is just about that big on the maps. We're the third smallest state. And our backyard, in my case Bethel, in your case Stanford or wherever you live, is a smaller piece of a small state that makes up a very small part of 1.5% of the Earth's surface. Okay? So what is happening in your backyard is very profound to you and I. That snowstorm we're likely to have on Saturday night, I believe, or what have you, but it only makes up a small part of the overall mosaic, which is the world. And so, how cold it is to us on Sunday or Monday, it's supposed to be really cold, as I remember looking at the weather report. And that very cold day here in Connecticut will contribute to the global average, but it'll just be a very small bit of influence on that global average. If we look at the global averages, the 10 hottest years in history, and our history goes back to 1880 because that's when we started collecting data that we could use to estimate what our global average is. Okay? The 10 hottest years globally defined are all since 1998. And we don't have the 2017 data in this graph yet, but I can give you a general idea of where it's
2018.
Oh, 2018, thank you. The 2018 data is going to be about yay big. I'm so glad you're paying attention. Yeah. Okay, so 2017. 2016 was the hottest year on record. It was also a strong El Nino. An El Nino and La Nina is a pattern that oscillates from one state to the other, flipping back and forth, having to do with the South Pacific, which affects the weather all over the world. Generally speaking, globally, El Ninos are warmer than average, and La Ninas are cooler than average. And La Ninas, the cooler one, actually means that we're likely to have more hurricanes. But the El Nino will have fewer hurricanes, but they'll probably be stronger because of the heat of the ocean, which we'll get to. So, generally speaking, 14, 15, 16, 17, and 18 is going to come out about right there. It's been warm lately. But the heat at the surface of the Earth is only part of the situation. There's a whole bunch of different parameters that are measured by scientists all over the world. And they're measured by different people at different parts of the world, and then we're able to combine everyone's data into global averages or averages that are appropriate for that particular point on the Earth. And these are scientists who may not be working together. They probably aren't. They may be, in fact, rivals. Scientists are just as petty as anyone else. And they like to, you know, do one better than the next scientist over. Okay? Sometimes. And so, scientists, if I go out and do a big study and publish some bit of work, there are a bunch of scientists who like nothing more than to prove that I'm wrong in some fashion. And that's one of the reasons that causes science to be self-correcting over time. It's also misunderstood by people who aren't scientists sometimes, thinking, oh, those people don't know what they're talking about. Well, this is how we get closer and closer and closer to reality, is by critiquing each other's work. Okay? That's just the way it is. All right, so if we look at a number of different parameters that are independent, they are not calculated one from the other. We're not calculating this one from this one. We're measuring it independently. And what we see is the glaciers are melting, the snow cover is melting, the tree is shifting towards the pole and upward in altitude. The spring is coming earlier, the sea ice is decreasing, the sea level is going up, and on and on. These are independent lines of evidence collected by different people in different places, and they're all pointing in the same direction. And that is that the world is warming. Okay? There's a particular concept which we see in science and in history and in some other academic fields of consilience. The notion is in consilience that the evidence from independent, unrelated sources can converge on to strong conclusions. If we have a whole bunch of different kinds of information that are all pointing us in the same direction, that gives scientists a great deal of confidence that what they say is basically true, although the details may shift. Okay? In fact, the great ideas of science, whether it be relativity or evolution or what have you, are all made firm and believable by the scientists of the world because of consilience, independent lines of evidence that are pointing in the same direction. So, when scientists seem cocky about saying, oh yeah, we know that the world is warming, it's because they got the data that they have every reason to be confident in those conclusions. Now, doesn't mean that other data can't come along and new ideas and prove something wrong, but with the vast amount of information we have and the common sense observations that you and I can make, it's pretty clear now, despite what the PR firms hired by the fossil fuel industries would have you believe, that the world is in fact warming and that we are largely responsible for that. And if you want to know why we're confident of that, I'm glad to explain it, but that's a different thing here. All right, now, one of the things we know, the reason we know, or one of the things we know has happened that's causing Earth to heat up is the fact that we are releasing certain gases into the atmosphere which absorb infrared. In fact, anybody here a chemist? Anybody here? How do you analyze the amount of carbon dioxide in the gas sample? One of the ways to do it is to run it through a gas chromatograph. But the other way to do it is to shine infrared through it and see how much is absorbed. In fact, I've got one of those gizmos. And the more CO2 there is in the sample, the more infrared that you shine through it, which is heat, is absorbed, and the warmer the gas is. Okay? There are other gases as well. Even water vapor is a weak greenhouse gas, but gases such as methane are strong greenhouse gases. The gases we use in our refrigerators and air conditioners, the CFCs, are hellaciously strong greenhouse gases. The more of those things there are in the atmosphere, the warmer it gets. The warmer it gets, the more the oceans heat up. As it turns out, most of the extra heat, which is trapped in the atmosphere by greenhouse gases, is absorbed by oceans. If you remember high school chemistry or college chemistry, you know that matter has something called a specific heat that will explain, it relates to how easily and how much heat can be absorbed by that material. Water has a higher specific heat than air does, and 93% of the heat that is trapped in the atmosphere is going into the oceans. Now, another way to look at the warming during a particular year, 2017 in this case, is to look at, and we can get this data from satellites confirmed by ground measurements, look at the distribution of which areas of the Earth's surface are warming faster during this year. It picked up more heat in this year than others. Okay? The areas which are in red are the warmest. Those that are in blue, and there isn't much this year, some years there's a little bit more, is cooling compared to a baseline. Okay? Remember how I said you had to have 30 years of data in order to describe a trend in climate? Well, the baseline that are used for comparisons may vary from graph to graph, but it's usually based on at least 30 years of data, and there you have it, 1951 to 1980, which is, yeah, 30 years inclusive. Well, compared to that baseline, you can see that the areas which are on this for this year, not terribly hot, were the blue blob here south of Greenland, which is cool because of the melting ocean water or the melting ice from Greenland, and often a few areas around the edge of Antarctica. And the areas that are the warmest are the Arctic. In fact, this is just 2017. The Arctic area here is warming up twice as fast as the rest of the world on average. In fact, there's an area called the Barents Sea right here that always throughout history has had a very extensive ice cover, but that ice cover is much less extensive than it was. And with more ice, the Barents Sea acts like part of the Arctic Ocean. With less ice, it acts like the Atlantic. And so warm water from the Atlantic is extending farther north into the Bering Sea and making it be different than it was before. We also have this thing called the polar vortex. And the polar vortex has to do with the comparison of the air mass at the pole and compared its temperature to the air mass in the temperate zone. And when the masses are high contrast in temperature and density, the jet stream between them is relatively straight. When the temperature difference is less profound, the jet stream is weaker and more wobbly. And what that does is it causes loops of cold air to be coming down to bother us at the same time that loops of warm air can be moving farther north. The blue is the cold in this case, and the red is the warmer. Now, look, if you will, that at the North Pole, it was very warm on that day. That day was February 10th, 2017. It was above freezing at the North Pole on that day. And it wasn't the only day. I mean, in years past, this sort of situation is extremely rare. It's becoming less rare all the time. Now, why should we care whether it's warming up at the pole and it's staying warmer there longer? Well, we care because of the ice that's up there. Now, generally speaking, let me tie my shoe. Generally speaking, the polar ice cap, which is floating, it's not sitting up on land, and so it is more easily influenced by the temperature of the ocean because the ocean's underneath it, will, generally speaking, will reach its maximum in March at the end of the winter, where its average you would expect to be where the white areas are. And the minimum would be in September, which you would expect to see around here. So that there would be opening up of ocean between the ice and the continent generally during the summer. Okay? And in Antarctica, the pattern is the opposite because the seasons are the opposite. Now, this ice in Antarctica is not the ice that's up on the continent is not displayed here because it doesn't really change that much in terms of visible mass over the course of the seasons, but the sea ice here that's floating does. Okay? So in the September, in the end of their summer, you've got a lot of sea ice, and in the winter, the end of their summer, you have less sea ice, and during the end of their winter, the end of their summer, you have less sea ice than the end of the winter. Now, when you replace ice with water, for instance, because the ice sheet has melted more, you're replacing a surface which is highly reflective with something which tends to absorb heat into the water. For instance, if we have a late season snowstorm, let's say in early March, and then we have a sunny day immediately after, and you're out driving around, you have to put your shades on because the sunlight reflecting off the snow is hard on your eyes. Okay? That reflectivity of the surface is something called albedo. All right? Now, as you might guess, a surface with a high albedo reflects more light and will cause that surface to melt slower. If you were to take that sunny, fresh snow and sprinkle wood ashes from your fireplace on a patch of it, you would expect that which is covered with the ashes to melt faster than that which isn't. Okay? When we have warm winters in the Arctic, we are forming less fresh snow. And we are losing more of our sea ice, so that the next year, when the sun is above the horizon, is shining on the surface, there is less white stuff to reflect that solar energy back up into space. And if it is not being reflected, it is being absorbed. Okay? And so, the warmer it is, the less sea ice. The less sea ice, the less reflective the surface is, and the more heat is absorbed by the ocean, which causes the ice to melt further. So it's a positive feedback loop. That's why we're worried about ice. The other reason we're worried about ice is that some of it is perched up on land. You all know that 20,000 years ago or so, this was an ice-covered area that was during the last ice age. In fact, right here was about a mile thick layer of ice. There was so much of the world's water tied up in ice that the sea level was very much lower, which is why Alaska and Siberia were connected. It's why Britain and Ireland were connected to the mainland of Europe, and why Australia and New Guinea were connected and so on. Well, the last piece of the last ice age is that big ice sheet on Greenland. That ice sheet on Greenland is melting like a hot popsicle on a hot summer day. And for two reasons. One is it's warming up. And the other reason is because of the ash and soot that is put up in the atmosphere by the industrial civilization upwind is blowing here and settling on this snow, reducing its albedo and making it melt faster. Now, when you take water from the ocean and warm it up, it expands. Thermal expansion. You can demonstrate that in any kitchen, okay, or any school laboratory. Warm water takes up more space than cold water does. So, that extra heat that is going into the ocean is causing that water to expand and take up more space. And when it does, the sea level rises a little bit. Okay? Now, this chunk of ice sitting on Greenland, this chunk of ice, which is so massive that the weight of it has smashed down and compressed the bedrock underneath it. So right here in the center, if you were to go down to bedrock, that bedrock is below sea level from the weight of the ice compressing it. I don't think of rocks as being compressible, but they are. If that ice were gone, over geological time, that rock would spring back up to its original or something higher. Well, anyway, that ice, which is sitting up above sea level, when it melts, all that water contributes to the ocean and the sea level comes up. Greenland. If you totally melted Greenland, as has happened in the past, it would raise sea level 7.36 meters, or a little over 24 feet. Now, another thing we don't really realize about Iceland, unless someone told you, is that ice flows. It will move downhill like water, like liquid water does, only just a lot slower. And so an ice sheet builds in the center, and then gradually, as that snow compresses the snow underneath it and compacts it into ice, that ice then will move downhill via gravity, just like water would, only, like you say, very slowly. Once it reaches the edge of the continent, it will extend out over the water and become something called an ice shelf. An ice sheet to an ice shelf. And that's when there's water underneath and air above it. So, at this point, that ice shelf is being exposed to the warming water of the ocean, which melts it faster because all that thermal mass in the ocean, and being exposed to the warming air on the surface, and these ice shells become thinner, and even in the old days of before the Industrial Revolution, eventually this ice would chunk off and form icebergs. One of the iceberg that that famous boat in 1912, the Titanic, ran into was a chunk off Jakobshavn, I think, ice shelf in Greenland. So, the warmer the water, the thinner the ice shelves and the faster that they chunk off, and as they do, with less of an ice shelf here, this ice behind it speeds up. Now, this applies also to Greenland as it does, or Antarctica as it does Greenland. I lived in Alaska for 13 years, and I've seen the Arctic Ocean. I've never been to Antarctica. Anybody here been to Antarctica? It's on my bucket list, but I don't know that it's high enough on my bucket list that I'll ever get to it. But Antarctica is a much larger mass of ice than Greenland is. Most of it is above sea level. It's actually two land masses. You've got West Antarctica and East Antarctica. East Antarctica is very high up. In fact, at the South Pole, you know, you're high, very high elevation. I can't remember exactly how high, but it's maybe a couple miles up. And West Antarctica here, and they're separated by a chain of mountains, trans-Antarctic mountains. If you want to know, the peninsula here points to South America. But a philosophical question to keep you up at night is, if you're standing at the South Pole, which way is north?
Everywhere.
Everywhere is north. Yeah. Everywhere is west, everywhere is east, too, for that matter. Okay, arbitrary. And West Antarctica as opposed to East Antarctica are arbitrary designations, but yeah, it's just easier for us to call them something, right? Well, East Antarctica is fairly stable. Those areas in blue here are those which, over the years 1994 to 2012, gained at least some mass. A little ice was added on. Those areas in red here are those areas where the ice decreased over that same time period. This area is cold, much colder, less in contact with the ocean, and more stable, although not perfectly stable. Okay. The West Antarctica is much less stable. There are the Larsen sheet up here have broken up. Pieces are falling off of it very rapidly. There are a couple of other big ice sheets, the Ross and the Ron here, which are massive. And just to make it more exciting, there's a chain of volcanoes underneath the ice over here in the West Antarctica, which have erupted in the past, and we have no way of predicting when they may erupt in the future. But West Antarctica is destabilizing fairly rapidly. East Antarctica, not very rapidly at all. Mass balance, you add it all up, and Antarctica is losing ice. Okay? Even though the eastern part of it, many parts are gaining a modest amount of ice. Now, if you took West Antarctica, the total melt of West Antarctica would raise sea level another 3.2 meters, another 10 feet. If the whole thing would go, if Greenland plus East plus West Antarctica were all to melt, it would raise the sea level up to the chin of the Statue of Liberty. And it has been that high in the past in Earth's history, not while humans were on the Earth. You have to remember that the Earth is billions of years old, okay? 4.7 billion years, I think. And humans have only, in our anatomically modern form, have only been around for 200,000 years, which isn't very long by comparison. It seems long to us because we live a certain amount of time, but you know, the theoretical woman, Mike van der Leeuw, who was the theoretical ancestor of us all, lived 200,000 years ago or so. That's only 10,000 generations, which seems like a lot, but it isn't. Right. So, why should we care about sea level rise? Even a modest 6-inch rise, even a modest 1-foot rise, why should we worry about that? Well, anybody recognize this place? That's Miami Beach, Florida. It's not the only place that's that close to sea level. My younger daughter, just spent a week in Vietnam, and she spent a whole day canoeing around the Mekong Delta, which actually has a lot of people in it because it's a very rich agricultural area. And it is right at sea level. 0 feet of elevation. It won't take much of a sea level rise to take a lot of very important agricultural land out of production there. In areas of Miami Beach, they built a seawall to try to keep the floods from coming in. The problem is that the geology underneath the city is very porous. It's like Swiss cheese. And so you could build a sea level all the way, a seawall up to here, and water would still come up underneath. And so it's an issue, and there's a lot of very pricey real estate there. Well, that's the question. See, how valuable is it? Well, it all depends. It's only as valuable as you can get someone to pay you for it. Now, at some point, the insurance companies are going to say, you know, I'm not sure I want to insure this. Now, right now, I think most of the flood insurance is probably coming through that federal flood insurance program, which last I heard was pretty much tapped out. You know, if Congress pours more money into it, it will keep it going for a while. But if you can't insure these buildings for flooding, will the mortgage banks issue mortgages on them? I think we know the answer to that. And at that point, how valuable is that real estate? In fact, by 2050, under certain scenarios, Miami Beach could look like that. Computer simulation show. In fact, if the sea level rises to 2 degrees Celsius, which is a very likely thing at this point, a very likely thing by the end of the century, this area in blue is likely to be underwater, all the way up to Lake Okeechobee. So you've got Miami, Homestead, Hollywood, Fort Lauderdale, and parts of Palm Beach and Naples and so on, Fort Myers. So a lot of people there, some of which have the means to move to other places, some of which don't, that are going to have to be moved. Anybody recognize this place? I spent a year in Bangkok. I spent a year in Thailand in the 70s when I was a kid. I was a foreign exchange student. I spent 2 or 3 months of it in Bangkok trying to learn the rudiments of the language. That was 1976 and 77, do the math. And Bangkok is a beautiful city, very historic, great food. You know, getting there is expensive, but being there is cheap. Anybody been to Thailand? Yeah. It's an amazing place. Okay? And I lived up in Chiang Mai during most of my time, which is higher elevation and far north, and sea level rise is not going to be an issue there. But in Bangkok, some areas are already below sea level, and you got 2 things going on. You have sea levels rising. You also have the land subsiding because they overbuilt some of the big, the taller buildings. When I was there in the 70s, the tallest building was about 17 floors. Now they're much higher than that. And the mass of those buildings causes them, gravity works and causes the land surface to move down. And the other thing too is there's an aquifer underneath, a reservoir of fresh water that has been pumped, you know, for domestic use in Bangkok. And so those empty air chambers also causing the land to subside. So sea level's going up and land is subsiding. My Thai brother is a professor at a college in Bangkok, and he says that the government is not making any plans for what to do about it. There's 10 million people in Bangkok, and within 15 years they're going to have to start moving people out, maybe before that. And no one's making any plans. If they make plans, they may spook the markets, and that's what they're concerned about. So, what do? If you're smart, if you're wise, I should say, not smart, you start early and start making plans of how these people are going to move in an orderly fashion to other parts of Thailand, Thailand's a pretty big country, and so there's plenty of room, but it's a disruption not only for the people moving, but to their new neighbors. If you're not wise, you put it off until you have no choice, then it's a big panic. And imagine 10 million people in a big panic. This is an island nation. This is just the main capital. It's called the Maldives, south of India and Sri Lanka. Apparently it's a lovely place to go scuba diving. I've not been there. But you can see this is the capital. I think the highest point in the whole country is like 1.5 meters above sea level. In this case, it's not a matter of flooding some areas of the country and they can move to other areas of the country. If Malay, the capital, floods, there isn't anywhere else to go. Because the whole country is, you can dip your toes in the ocean. What do you do with a whole country that's underneath water? This is a delta formed by the flow of the Ganges and Brahmaputra rivers. In this huge delta, which is formed on the northeast coast of India and about half of Bangladesh. And it is made up of mostly farmers who are growing rice and other crops in the delta, which is fertile because of the sediments that are washed in from the monsoons every year. But there are 16 million people within 1 meter of sea level. Now, I'm not sure there's enough room to settle 16 million people. Maybe there are in other parts of Bangladesh, but it would be an awful thing to try. And India's got their slice of this terrain as well, and it's going to be a tough thing. And so the question is then, this isn't all of it that is going to have this situation. New Orleans, Houston, Shanghai, Bangkok, Jakarta, Manila, Tokyo, Yokohama, London, most of the Netherlands, Alexandria, and the Nile Delta, and Lagos, Nigeria, and I could go on and on. These are Rio de Janeiro, the areas that are not up on the hills. These are areas where within this century we're likely to see massive numbers of people moving away from the coast. And you're not only losing the homes those people have had, but you're also flooding some of the best agricultural land in the world. And the Nile Delta. How is Egypt going to feed its population if the Nile Delta is below water? I don't have an answer for that. Well, climate change is going to cause not only sea level rise. In some ways, that's the worst of it, I think. But there's going to be an increased amount of severe weather. This is just some of the things that have happened in 2018, and in some areas we have, these are areas that the cleanup of which cost at least $1 billion. So we've got wildfires in the west, you have droughts in the southeast, and hailstorms, and hurricanes, and so on. And the warmer the ocean is, the bigger and the wetter and stronger those hurricanes are going to be. Nor'easters that we are so fond of here. are going to be more. How many nor'easters did we have last year? I think we had 4 in March alone, didn't we? One of them, that one that flooded Boston, hit right when my daughter was trying to catch a flight back from Amsterdam from her study abroad. Luckily, her aunt, my wife's sister, lives in London, and she could hang out with Aunt Dorothy until she could catch a flight, but not everyone was so lucky. Hurricanes gain their energy from the temperature of the ocean. The warmer the ocean, the stronger, the more energy they are. And we have hurricanes, of course, in the Atlantic, but the big ones are in the Pacific. And the reason why there are more stronger hurricanes in the Pacific is there's just an awful lot more Pacific for those hurricanes to run over and build up steam. They're called different things. We call them hurricanes here, they're called cyclones in the Indian Ocean and typhoons in Asia. You have something called super typhoons in Asia. There was one, Typhoon Tip, I think, which if you took the size of that hurricane and laid it over the map of the U.S., would cover most of the land west of the Mississippi. And of course, the hurricanes are not just the wind, but they're also the storm surge. A 6-inch increase in sea level may not seem like anything, but when you add that on top of whatever the storm surge is for the next Sandy to come through here, or the next monster nor'easter, then that's just extra on top of what would be there otherwise. And more damage, more loss of lives, loss of homes, and so on. I'll be, spring break, I'll be with a bunch of students, and my students in Puerto Rico cleaning up